Hi everyone, today we're going to continue this series on Wordle. Today's video is going to focus on continuing to correct some of the mistakes that we've seen in tests, as well as to work on further abstraction. So right now we have sort of one big file with lots of little pieces to it, and today's video is going to show breaking this up into smaller files and then using export lists to create abstraction barriers and to sort of clean up the code a little bit. I'm hoping by the end of this video we'll actually have things working so that we can then get to what we were hoping for and actually be able to analyze Wordle guesses correctly. We're slowly inching there, but there's a lot of fun things that we've seen along the way. So the other fun announcement that I'm happy to make here is that I actually have Haskell language server working once again, thanks to some help on that ticket. Which will be linked in the description. The bottom line is that VS Code doesn't install the right Haskell language server on new Macs, the M1 Macs. So we get the wrong version of Haskell language server, and that works most of the time, but not all of the time. So I just had to recompile it myself locally, and then now things are working. So first step, let's go through and sort of see about any of these HLint warnings that we're getting. So here, let's see. Oh, sure, let's hoist that not. Let's apply the hint. That does look a little bit better. Not any letter is in location, the no location. That's good. Let's see what other errors we have. Do I have other errors? Thought I did. No, I guess not. Excellent. Okay, good. Let's see. The other little sort of housekeeping thing that I wanted to show is when I run cabal test, this is going to compile and run a little bit. We should see a failure because we know that there's something wrong. We know that when there are repeated letters, that this same response property fails. Let's remind ourselves what the same response property is. Same response, it's valid words with same response. So let's take a look at that. Oh, look at this. HLS is working. We get all of these nice little indications. Oh, and there are still mistakes. I wonder why that other button didn't find them. Sure. So we have this funny lambda here. Let's just fix that. And let's fix it down here as well. Excellent. So here, what is this saying? This is saying that if I respond, so I have a guess. So this is the answer that I'm supposing is the right answer. This is one particular guess. Then we track that in our state, and then we're going to filter based on that. Well, now everything that we've kept should produce the same response. If it doesn't produce the same response, we should have filtered it out because it means it's inconsistent with the information that we have in our state. And yet we run into a problem. So here with adapt and elate, we don't have this property. So that must mean that there's some word, it actually doesn't get printed out here, that when my guess is adapt and my answer is elate, we get something funny going on. So let's actually see what that looks like. If I do cobble REPL, I can load this in, and then I think I have to import Wordle, and let's see, respond to guess, adapt, elate. Oh, doesn't like that. Oh, I probably need to enable overloaded strings, but I want to do this set I, so it only affects my my terminal. It doesn't affect any files that I try to compile here in GHCI. So let's, oh dear. I thought I had fixed that problem. I'm going to have to quit, and then this needs to be term equals dumb. I thought term was always dumb right now for me, but I guess not. Cabal REPL. Okay, we have to do that again, and then import Wordle, and then hopefully this will produce an answer. Okay, so let's look at this. So x, y, x, g, x, y. So the A here is labeled y, and then this second A is labeled G. So this is problematic because it looks like there should be two A's. If I have a Y and a G for the two different A's, that means that there should be two A's in my answer. So that's the problem. The problem is that respond to guess is malfunctioning. Last time Oh, wait. There's one thing. So this is, before I get to that last time. So we see here that there's a bug. There's another problem, though, is that if I run cobble test again, this is going to chug a little bit. And then now I see that Plaza and Crank has a problem. And what's strange here is that testing is really meant to show where I have bugs in my program. It's a little bit awkward if every time I run the test, we get different results. So I want to go and change my testing setup just a tiny bit to avoid that problem. And so we can look in the Tasty framework. What I want to do here is I want to set some options. In particular, I want to set an option that says to quick check, don't use any random number, just use this particular seed that I will provide. So the way that options work in Tasty is I can take a test tree and modify the options over that test tree. So in this case, I want to use local option to set a particular option. Well, what option? Let's go to Tasty quick check. And let's see here in Tasty quick check, if we look through here, we see quick check replay. And quick check replay can set a particular seed to use for quick check. So let's see this in practice. So my property-based tests, what I want to do is I want to set local options. That's over here. Oh, sorry, local option, excuse me. And my local option is option, but this quick check replay has that instance. Excellent. So then I choose this quick check replay. And then I need to pass in an int. I don't really care what the int is going to be. 1, 2, 3, 4, 5 will work just fine. And then, well, maybe I'll put this over here. Now I'm going to get consistent behavior, or at least I hope. So let me try cobble test here. And this will compile and link and run. And indeed we get an error. Now it's Otter and Fritz. Notice the double letter. And that letter appears in the answer. I think that's always going to be the case. Let's run it again. And we still see Otter and Fritz. And it even says use quick check replay 1, 2, 3, 4, 5. So that's my 1, 2, 3, 4, 5 here. Excellent. So that means that now I have deterministic tests. That's a very good thing. Okay. Going back to what we did last time. So last time we spent most of the video changing the representation for Wordle words. So this is going to be in words.hs. Not to just be a vector of characters, but instead to use a map from characters to sets of locations. And that's my new word representation. And we're going to see how that word representation works better for actually getting correct answers. So now let's jump back over here. And we wanted to fix, let's see, where is it? respondToGuess. And here, let's see, how does respondToGuess work today? Well, it does a zip width of the green spots, which are the areas that should be green. And this is very simple. This is just looking at the letters in guess versus the letters in answer. Although this get letters now does a lot of work. If we actually worked over our new internal representation, then maybe we could be more efficient. This is one example of a very common phenomenon in which abstraction and efficiency are a little bit at odds, right? Because here, this get letters is very nicely abstract. It converts my internal representation to this nice vector of characters. But actually, there's a better way of doing it now that we have a more efficient representation. So we're going to have to look under the abstraction a little bit. So let's see. So first we do that. And then I guess we're running convert, taking these green spots. So if it's green, then we want to return green. Otherwise, it's not green. And then we check, is it somewhere in the word or is it not? So I'm going to take this and I want the same type. That's a very good type for respondToGuess. But actually, I'm going to junk this whole implementation. And I want to reimagine the implementation using these internal word representations. And so that's what was it again? Oh, wait, can I just point at this and it'll tell me? Oh, no, it won't do that. So let's see here. McWord, that's the constructor. So we have McWord guess rep and McWord answer rep, where these reps equals undefined. Let's see, we'll get rid of these weird errors. Oh, good. Now we get more information. We get that answer rep has type word representation. And let's get the REPL working here. Actually, I think I have that. Yes, there we go. That's going to load nicely. Okay, so defined but not used. Okay, 2 modules loaded. Excellent. But now, hopefully, I can query what word representation is and see it right here. Excellent. I can see that it's a map from characters to sets of locations. So let's think what we want to do. Well, what we want to do is we want to take characters in common between these 2 mappings, and if the sets overlap, those are going to be green spots. And then we'll do something else. We're going to do the same thing. We're going to figure out the green spots first, I think, and then we'll worry about the others. But let's sort of at least figure out the green spots. So for this, what I want to really do is I want to take these 2 maps and essentially zip them together, I think. Yes. Is that a thing? I suppose so. There's probably union with. If I had a function that did that, it would be called union with. So let's go up to the top here and see about unions. So we have union, which does a left bias union. I don't want that at all. I want this. I want a function. Union with, this takes A to A to A. I don't want A to A to A. I want something else, because the type out here is going to end up to be a tuple, sort of a pair of sets. I want the set of locations in my guess and then the set of locations in my answer so that I can compare them. Do I have a function that does that kind of thing? No, it looks like I'm going to have to do something clever, like actually compute things along the way. Let's see. Cleverness is hard to do when in a video. Definitely want to do some kind of union with. We'll just say go. There, I've written a line of code. That can't hurt. Okay, I want m.union with, and then where, and if I point here, go, it even tells me the type of it. Excellent, thank you, HLS. So this works over, it would be s.set, wouldn't it? Set of location. And it says that my answer is going to be a set of location. Why does it know that? Oh, because union with keeps things of the same type. So the reason that it has to do that is that there's a chance that there's some character that's represented in one but not the other. And so we need to have some value to have there, and it's going to have type A. But I don't really want, I think, to produce a set of locations. Oh, maybe I do. Maybe I do. Let's see what happens here. So maybe what this really is this is the green locations. But then I'm going to just get the characters mapping there, and I don't really care about the characters at this point. But let's see what happens. So this is going to be a map from character to set of location, where the green locations is the result of this union with. And then I'm just going to put that there so we don't have weird parse errors. Okay. Now this go, I'm going to make this a local function here because it's just part of this green locations thing. And what is this going to do? So this is going to take the sets and, all it has to do is perform an intersection, right? Because this is, we will have the set of locations for the letter A, say, and the set of locations for the letter A in the answer, and wherever they overlap, that should be the green spots. Okay, So that's just intersection. Data.set, I'm sure there's an intersection function. And that does exactly what I want it to do. Excellent. So go, well, I don't even have to do that. I can just say, is it called intersection? Yeah. So I can just say union with intersection. It's s.intersection. Okay, so this should be my green locations. Cool. Let's just sort of test this to see if this is at all sensible. So I want to just do m.union with s.intersection, and then how do I get the thing out? Oh, I don't have a little accessor function. Let's see, get word representation. Okay, so now I'm going to get my little accessor function. So, blah. Let's reload down here. And that's defined but not used. But now I can start to say this. Get word representation of, what's an erroneous case here? Otter and Fritz. So we can do otter and then get word representation Fritz. Not in scope. Get word what have I done wrong? Oh, haha, I can't spell. Representation. Now what do I have? Can't match expected type Wordle word with actual type car. This is this overloaded strings. Let's turn that on again. Aha. Okay. So here we get E maps to 3. So Fritz or Otter and Fritz. So E maps to 3, F maps to 0, I maps to 2. Something's very wrong here. I don't like this at all. I was hoping that all of the locations in here would be green locations, where there should actually be none, because I don't think Otter and Fritz have any greens in them. No, they do not. No, they do not. So this should have nothing. So the problem here is that Otter is in this first word. It's in my guess, but it's not in my answer. And so union with just sort of takes it and carries it along, and it never applies this s.intersection thing. So that's not what I want. Instead of union with, maybe I really want intersection with. Is that a thing? Let's hope it is. So here we're going to have intersection. Aha! We have intersection with, oh yay! Oh yay! This has a combining function that has multiple different types, which is exactly what I wanted. So this whole union with, that was just me being silly. What I really want is, and now I can do a better job in that, let's see, things that are only in the, things that are only in the guess but not the answer at all, is not included in the representation at all, those are going to be gray. So actually, I think in the end, what I'm going to have is I'm going to have one of these sort of map from characters to sets of locations, but it's not going to be a map from characters anymore. It's going to be a map from, what are these? Letter response to different locations. That's, I think, what I'm going to get out of the end of this process. So that suggests that in here in words, instead of word representation always going from cars, I want to be able to vary the key. And this is going to be a word representation car. And let's see, there's errors somewhere. Oh, here, this is a word representation car. And this is a word representation car. Okay, good. Okay, let's see. So that's fixed. So now my response, instead of being a vec5 of letter response, it's going to be a word representation of letter response, if I could spell. And then Now I am going to want this get responses. I'm still going to want this, but this, I've already written this function. This function is already written here, and it's called get letters. But now I realize that it's parametric in the key type. So this can work for any key, and it's going to produce this key. Oh, but now this takes a Wordle word key. So maybe I really want to keep this the way it was, but now get letters from word representation. Rep. I'm just going to call it rep. That's much easier to spell. Let's do that uniformly because I'm tired of misspelling that word. Okay, so get letters from word rep, or I guess this is really not always letters. Get keys from word rep, or it's really get vec5 from word rep. That's really what I want. So this is going to be a word rep key to vec5 key, and then this whole function here, that's going to be my definition. So this is get vec5 from word rep, except now it just gets past the mapping, and everything else should just kind of work. And then now here, all I have to do is call get vec5 from word rep mapping, and then I can delete all of this stuff, and hopefully that just works. Oh, but now I have to, of course, fix this. Okay, and there's still problems. Couldn't match type key with car. Oh, that's because here I've just said that, but I really want this to be key. And now couldn't match type key 1 with car. Well, I don't know why there should be any characters. Aha, it's here. This is key. This is key. I'm still expecting some problems. Couldn't match key with car. There's still some car trouble. Aha. Okay, couldn't match type key 1 with key. I was expecting that. And that's because by default, Haskell doesn't bring this key into scope down here. Instead, I need to explicitly bring it into scope by saying for all key, and I need to have scope type variables on, but I already have that actually. But now all of the keys are the same. So now let's see, we still have a car problem. Let's probably change this to key and see if that gets rid of the problem. Oh, it does, excellent. Okay, so that was pretty easy. We just generalized this function, this get letters function, now to get vec5 from word rep. And so now get responses can just call get vec5 from word rep of ours. Because this is a word rep and this is a vec5, so that should just work. Let's see here, and there's some other problems. Can catmap show v.toList get vector responses? What's the problem here? Responses. Oh, I see. It wants a vec5. Well, of course it wants a vec5. So I'll just use get, get responses. Get responses. I have this is show response. I think I want this, and then get responses of response. There we go. Excellent. And down here, what's my problem? From list couldn't match. Oh, I'm doing the same thing, aren't I? That's because I'm calling mc response. So here, this is sort of going the other way, but I already did that as well. So over here in words, I have mcwordle word, which goes from a vec5, but now I really don't want this to be mcwordle word. Let me make this mcword rep from vec5. And so this goes vec5 of some key type to a word rep from that same key type. And I'm hopeful that this implementation, just sort of like I did the trick a minute ago, the implementation should still work. And here it's mcword rep from vec5. And now I'm not making a word in the end. I'm just making the word rep. So let's see what we get here. So this is get vector. Couldn't match key with car. Up here, I probably need to change this to key and that to key. And then I need to bring key into scope. And so now there's still some trouble. Aha, this is still car. And now what? No instance for ordered key. Well, it does make sense that the key would have to be an ordered thing for this to work. So let's just put that up there. That works. Excellent. So now this can just change to McWord rep from vec5 of vec, and then I can get rid of all of this stuff here. So now things are getting a little confusing because I have word rep stuff with Wordle word stuff. So let's reorganize the code. And then now I'm just going to have sort of a word rep section. Let's see. So that's word rep, and then this is still word rep. And now I can make another one of my little sections. And this is the Wordle word section. This is the word rep section. Okay. Excellent. And all of this is really specific to Wordle words, but it's quite simple, which is good. And then now over here, my, let's see, I'm having trouble over here because I have input, which is a string, and now I'm calling mook response, and I need a word rep from a vec5. So probably all of that's okay, but now I need McWord rep from vec5 of all of that stuff, I hope. No instance for ORed letter response. Well, let's make one. That seems pretty sensible thing to do. And aha, excellent. Okay, so we've done that. So we now have responses working. Now that I've done all of that, I can come back here and let's see. So now that's right. I decided that instead of union with, I need intersection with. And then we're going to have intersection with, well, hold on. Let's not jump ahead here. This is not going to be union with, but this is going to be intersection with. And what I wanted to do is I wanted to then try this down here. So let's just see what happens if I do intersection with. And then here, indeed, I get no locations. But I do get this R and this T, which is a good thing because R and T are exactly the ones that should be yellow. It doesn't quite give me enough information to do what I want. And I think that's because I don't really want intersection here. I want something more glorious. Now that we realize that we're going to be not just computing green locations, but these are sort of green and yellow locations or something like that. Maybe we'll refine that again in a minute. And so this isn't going to be just s.intersection, but some kind of go function. Where go, what type should go have? Okay, does this set of location, but let's leave room for comments because when we have this many of the same type, it's very important to label them. So locations of a given letter in the guess, locations of a given letter in the answer, and then this, well, already I'm in trouble because I don't really want a set of locations here in the end. I want this not to be a map car set locations. I really want map letter response. But now I'm in trouble because intersection with does not do this thing. So maybe that's not going to quite work. But actually, in the end, I want a set of green locations and a set of yellow locations. So if I do this, then my go here, well, there's going to be a problem. This really should return two sets of locations. Green locations, yellow locations. Okay, let's give that a try. So guess lokes, answer lokes. Let's see. And how am I going to compute these? Well, So this is going to be green lokes and yellow lokes, where green lokes, well, let's see, to figure out the green locations, that's really going to be the locations in common between guess rep and answer rep. But the key thing here is that I want to, when I mark a location as green, I sort of want to remove that from the set of locations in the answer so that I know where to look for yellows, right? Let's look at our Otter and Fritz again for a sec. Actually, Otter and Fritz don't have this particular problem. They're going to have a different related problem. So let's think about a different case here. What about the case of what would work here? Adapt and what's another good word? Adept. Sure, adapt. Oh, I didn't really even mean for them to be quite so similar, but it will illustrate the point. The point is that this first A should be marked as green, and then this second A really should be marked as gray because the green has already been used up, right? There's not another A in my answer. And so here, so when we do these green locations, what I want to do is I want to take answer rep and subtract out the locations in guess rep. So here, the green locations is going to be answer rep intersect guess rep, and then the places where they intersect. Oh, why am I getting an error here? Whoop, not in scope. Oh, intersection. Excuse me. Okay, couldn't match type map with set. Oh, I don't want answer rep here. I want answer lokes and guess lokes. Okay. And yellow lokes, yes, I know it's not defined. We'll come back to that in a minute. Okay, so these are going to be my green locations. But what I also want to do is I want to store my answer lokes that aren't related to the green location. So this is going to be my answer lokes s dot difference from the guess lokes. So this is going to actually remove from answer lokes the ones that appear in guess lokes. It would be nice to be able to sort of compute the intersection and the difference at the same time because these are really similar operations. Do we have anything like that? What would that be? Let's just see if I do this spotlight thing, if I can find it. So this is going to be, it takes a set A and another set A, and it's going to return two sets. No, nothing found. That's a little sad. Some kind of foldy thing can probably do it, but I'm not going to figure that out right now live in the video. Okay. So we have the green lokes, the answer lokes not green. Now, the yellow locations are going to be, well, we sort of need to do the same thing. Every time, what I want to do now is I want to find locations that are in my guess that are in answer lokes not green, but every time I use an answer loke, I need to remove it. So what am I really trying to say here? Well, my guess lokes. Oh, and I only care about the guess locations that aren't green. So I also want guess lokes not green is guess lokes, and I'm going to remove out all the green locations, all the spots that we've already marked as green. So let's do running example, because it's really hard to sort of keep all of this straight in my head. Do I really want adapt and adept? No, probably not. Let's have adapt and, I almost said adage, but I want something without an A there. No, I don't want adopt. That's too similar. How about adore? Adore is a nice word. Okay, this has a nice mix of different things. So green lokes, this is going to be, but here everything is in terms of one particular character. So for A, we're going to have the green lokes, it should just be the set containing 0. Answer lokes not green, in this case, is going to be the empty set, because I don't have any extra A's over here that have not yet been accounted for. And guess lokes not green. This is going to be location 2, because this is guess lokes. So guess lokes equals for A, this is going to be 0, 2. And answer lokes for A, it's going to just be 0. Okay, so guess lokes not green is going to be just location 2. And really what I want to do is for each guess lokes not green, I want to treat these in order for each answer lokes not green. I know that the sets are going to be disjoint by the way that I've set things up here. So the yellow lokes is going to be, I need to do something sort of for each, for the first N, N answer lokes not green is going to be S dot, is it size? Yes, the number of elements in the set. Excellent. S dot size of answer lokes not green. And so for A, this is 0, because I have no leftover A's. And then what I want to do is I want to take the first N elements of guess lokes not green and map those to yellow. And then the rest, I've sort of used up all of the letters, and then the rest need to go gray. So now gray is getting involved. Well, let's just sort of figure this out. So yellow lokes, well, let's see. So yellow lokes list, because I want these, this is going to end up to be a list. So what we're going to do here is I need to get the elements of a set. Is that conversion? I guess that's conversion. Okay, 2 ascending lists. Yes, I definitely want 2 ascending list here. So this is going to be 2 ascending list of guess lokes not green. I actually tested this in Wordle once upon a time, that it will label the first one as yellow and then later ones as gray. So we're going to do this. And here, now I want to take from this list and, well, I want to actually split. Let's see, is there a function split? Whatever that is, I don't want that. Set any, there's something very strange is going on there. I want to say split. I think there's a function split at, is there not? Yes, split at, that's the function I want. Excellent. And it has the right type. So split at N answer lokes not green. I want to split there, and then we're going to get the yellow lokes list, and then gray lokes list. Okay, good. And then my yellow lokes is going to be changing the yellow lokes list into a set, and then, oh, yeah, that's it. So s.from list yellow lokes list. Excellent. And now so this gray looks list, we're going to have to work out what to do with that. Maybe we calculate them all at the same time, because this gray looks list, I think that this is going to work all the time, actually. Oh, no. So this, because I'm doing intersection with, this function is only going to be run for things that appear in both the word and the answer. So this is going to give me some gray locations, but then there's going to be some more. But we're going to get another set of location here. Some gray locations, not all of them. And here, this is going to be gray lokes is from list of gray lokes list. Okay, so now we're going to get green lokes, yellow lokes, and gray lokes. But we're going to have to sort of combine this with stuff that didn't get processed in the intersection with. So I'm going to call this GYG locations, green, yellow, gray. And it actually returns 3 sets of locations. Okay, so this all type checks, but it doesn't give us our final answer. And that's because I need to figure out sort of the unused, or we're just going to call them bad letters. And this is actually going to be, I guess, a set of characters. And these are the letters that are in the guess but are completely that are completely missing from the answer. So bad letters is, so this is going to be a mappy kind of thing. I want to subtract, difference. The difference of 2 maps. Return elements of the first map not existing in the second map. That's exactly what I want. And then there's difference with a combining function. When 2 equal keys are encountered, the combining function is applied to the values of these keys. If it returns nothing, the element is discarded. If it returns just, the element is updated with a new value. But this gives me A again. I don't want A again. Well, let's think about that another time. There's something promising there, but I don't know exactly what. And I'm wondering why this needs to be maybe A. I could think about that harder, perhaps. But difference, that's really what I'm after at this moment. So here, the bad letters are going to be guess rep m.difference. Oops, this needs to be in backticks. Answer rep. And that will give me the map, but I don't want the map. I just want the keys of the map. That's the interesting part here, I think. Oh, no. No. I want bad locations, not bad letters. Bad locations. And this is going to be a set of locations. This is guess rep, difference answer rep. So that gives me the map. But now I just want to extract out the values. So let's see. Construction, query, traversal. Maybe traversal? No. I don't want any of these map stuff. I sort of want to fold. But let's see. Can I just get the values? Is there a function called values? Maybe. No. Let's see. I want fold. Oh, maybe what I really want is, do I have fold map? Oh, I only have fold map with key. Oh, that's because I bet a map is actually a foldable and I can just use the normal foldable. Yes, it is a foldable. Excellent. Okay, so now I know what to do. So I get this difference map, and then I want to combine all of these. So that is precisely fold. Oh, I don't even need fold map. I think I just need fold, right? What's fold? plain old fold. Yes, foldable T, monoid M. So what this is going to do is that this is because, let me sort of work my way through this for a sec. This bit over here is going to be one of these word rep cars. So it's going to be a map from characters to a set of locations. By folding them, it's going to combine all of the locations. That's exactly what I want. But it's saying that fold isn't in scope. Then let's import qualified data.foldable as f, so that I can say here f.fold. And that's indeed going to be the set of locations of things that don't appear at all in the answer. So that's pretty good. Now, having done this, so now we have all of these locations. We just need to build up the maps accordingly. But that shouldn't be so bad. We're going to do m.fromList. And then now we just make pairs. So we're going to get green maps to, well, these are GYG locations, but it's this map car thing. I don't really want a map car. I just want the values. So instead of making a map car, I'm just going to use fold again. And that will get me exactly what I want. So now that I've done that, and now I can say instead of GYG locations, that's not all that helpful. Let me get rid of the type signature because it's not going to be all that helpful. That we want green locations, yellow locations, and some gray locations. And I'm careful to spell this out instead of this lokes here. Although now I'm confused. Is this, this is sort of per letter and this is overall because I've folded all of the letters together. So green will map to green locations. Let's see over here. Yellow will map to yellow locations. And gray will map to bad locations combined with some gray locations. Because there's two ways of getting gray. One is we've run out of letters, and then the other is that the letter isn't there at all. Let's see. Why do I have an error? I don't want an error. Oh, couldn't match. Oh, we just, this isn't a response yet because we haven't called mcresponse. Indeed. Okay. That seems to compile. Let's load here. It's thinking. Excellent. Let's import Wordle. And let's do, we tried it a while ago, respondToGuess, adapt, and elate. So when I respondToGuess, adapt, and elate, then indeed this A gets marked as green and this A gets marked as gray. Excellent. It took this very careful analysis to do it. Let's check out respondToGuess of Otter and Fritz. XYXXY. So this is saying that there is a T in my final response, but not here. But then there's not a second T, so this T gets an X. My previous implementation did not do that. So this respondToGuess works much better now. So let's just get rid of this now dead code. But because I had this nice sort of abstract type for response, I don't have to make other changes. I think we're ready to run the tests again. So let's quit out and let's do a test run. And let's see, so we get a failure. I was hoping for this one to work. So now various things don't work. Otter and Fritz. The Wordle property fails with Otter and Fritz. And then this also fails. So I liked my respondToGuess. So let's take a closer look at these tests and try to see why these didn't work. So the Wordle property, good, there's a comment. For a given guess answer, the answer must remain a valid possibility after filtering based on the response. Ooh, that's pretty ominous. So if I load this, import Wordle, so this is Otter and Fritz again. So let's look. Let's see. Let response equals respond to guess. Whoops, I need that quotes. This again. Okay, so response. Am I happy with this response? So O is not in the answer. There's one T in the answer. E is not in the answer. And there is one R in the answer. That looks like a pretty good response. So let new state equal advanceState starting state Otter response. And then let's look at this new state. So we say here E is not in word, good. O is not in word. R is in the word. We don't know where it must be, but we know it can't be in location 4. That's good. And then we get T, oh dear. T is not in word. No. T is in the word. It's just, well, this is interesting, isn't it? Because now what I'm realizing is that in the analysis, let's see, where is it? Advancing the state. Well, gray doesn't necessarily mean letter not in word, because here, this T does get a gray, but that doesn't mean it's not in the word. So I think what we need to do is we need to have a subtler notion of sort of counting the number of times a letter might appear in the answer. That the way that we've modeled our state is not fine enough. Ooh, that's very interesting. I do think we're going to leave that to another video to explore, however. But I do want to fulfill the promise that I said at the beginning, which is I've been making these little sections in my files just to sort of keep myself organized. I think it's time to break things out into separate files. So let's just go ahead and do that, and we can see a little bit about how that goes. So this response type, well, let's move all of this out into its own file because it's all to do with responses. So we're going to cut that from here, and I want to make a new file, module response, and we're going to save this as response.hs and paste that in. And there's going to be lots of problems because we need all of these imports. So in the end, we might thin the imports, but for now, let's keep them. Okay, so now we've done this. Oh, and I missed some imports. We need to import words, of course, and probably this other one too. So let's just copy them all. Oh, it seems like there's some formatting happening when I paste. Oh, this is not a known bug anymore. Excellent. I can delete that. Okay, so response is happy. But now that I've removed response from here, there's going to be errors. So now I need to import response. Okay, and this is happy. Good. Okay, so that was one section. But what I actually want to do is I want to go one small step further and say I want to put an export list here. I don't need anything to know how my responses are. I just want to export the response type and then maybe a few other things. So response, I think we're going to need a letter response. That's not meant to be abstract. So I can export the constructors for letter response. And then I want some functions. So actually I want letter response first because that's a little bit more primitive. And then we'll take response, but I'll spell it correctly. And let's see, we need get responses. RespondToGuess. And let's see, is that enough? The interesting thing here is that I haven't exported the fact that I'm storing a response as this funny little map type. And that means that that over here, I just don't have to worry about that aspect because I know that I've kept it abstract. And all of this works fine, but over here in test, now there's problems because I haven't imported enough. So I'm also going to import response. And now things are almost good, but if I try to do cobble test here, I think I'm going to run into trouble. Could not find module response. And that's because I need to also list it in my cabal file here. So in my library, I now have a new module response. So I put that there. And I think, is that it? Let's give this a try. Yes. So we still see the same failures, but now I've made my code a little bit more organized by moving all of the response stuff out to one file and then adding a little abstraction barrier. I could keep doing that. I'm not going to do that in the video right now. It's not very interesting to keep doing that. It's because it's not a very sort of challenging operation. Ooh, what's all of this? This is old code. Let's get rid. Let's get rid of old code more carefully. Okay. So that's a good thing. And we can keep doing that. I think I'm going to do that between videos a little bit, so things will be a little bit refreshed in the Git repo and for the next video. So let's see. So where do we go from here? Well, it looks like we still have some bugs to fix. I was hoping not to have any bugs at the end of this one. But it does seem that this advanced state is not quite right. So we need to think a little bit more about how we want to represent our state. Again, this is the art of software development, right? We sort of start from the beginning and we think, okay, I think I know how to model my problem. But actually, as we build out, as we add tests and we see the test fail, we realize that the model that we've had in mind may not be exactly the right one, and we have to keep refining it. And as we do so, things get more and more, we maybe have more data structures, a little bit more logic, but then we also have the tests to back us up so that we know that as we continue editing, we're not regressing, we're not introducing new mistakes. So I think that's it for this one. Thanks very much for watching. Bye.